someone be kind enough to just press the red button for me? Starts ready? Okay, good, awesome. So the difference between Kirchoff's law the hint for you to know when to apply Kirchoff's law is very simple. When you see one battery, no need Kirchoff's law. Very easy one. Like say for example, if you see this one, come on, seriously, you know how to solve this kind of question in like year 3 already, year 4. You don't need another law to know how to solve it. But what I'm going to show you is that how Kirchoff's law apply for multiple EMF sources, and actually what you did previously in year 4 is actually using Kirchoff's law unknowingly. Okay? So what we're going to learn is something deeper that applies to something that you learned beforehand. So let's talk about Kirchoff's law number 1. You'll be so surprised that, hey, why is it that it's so simple? I could have come up with this law as well. Actually, I kind of agree with you if you had that feeling. So what is Kirchoff's first law? By the way, the full spelling is Kirchoff. Sounds like a Russian, right? Sounds like a Russian. Kirchoff. Kirchoff. Like some badass guy in some Hollywood movie. Kirchoff. Kirchoff is going to come after you. Kirchoff. Okay, so what does Kirchoff say? Kirchoff says that, okay, I1, I2, I3. Very simple. Based on the conservation of charges, whatever current that flows into a junction where the circuit connects must be equal to the current flowing out. As simple as that. So therefore, I1 is equal to I2 plus I3. Okay? It's like, wow, this is a first law. Actually, it's really simple, as you can see. Conservation of charge. What is really important and more challenging is Kirchoff's second law. Now what Kirchoff's second law says is that the sum of EMF in a loop is equal to the sum of PD in a loop. Sum of EMF in a loop is equal to sum of PD in a loop. Now let's apply it to a simple circuit like this. Then I'll show you how it applies to a more complicated circuit. So 8 volts A, B, this is VA, this is VB. So what it says is sum of EMF is equal to 8 volts. The convention is always to take the EMF direction as pointing from negative to positive. So it points from here to here. And we take, say, this direction to be positive. So sum of EMF is equal to 8 volts. Not negative 8 volts, but 8 volts. Sum of PD, we define the direction of current to be here. So the PD points in the direction of the current. Therefore, it is equal to VA plus VB. So therefore, 8 volts equals to VA plus VB, which is what you have learned beforehand. Okay? Now you can always take the convention as the other way around, which means that if I were to do AB this way, 8 volts, it points this way, I take this direction to be positive. It still works, which means that minus 8 is equals to minus VA minus VB, which is still the same equation that you had earlier on. So which direction you take to be positive, this way or this way, you end up with the same equation. You don't have to worry about direction that you take to be positive. Easy, right? Easy or not? Now we're going to go off to something that is not so easy. What if you have a circuit that looks like this? Let's throw in numbers so that it's easier for you to visualize. 8 volts, 16 volts, 10 volts, 2 ohm, 3 ohm, 4 ohm. No, let's say 6 ohms. Okay? So there are 3 currents that we're talking about over here, I1, I2, I3. Now I'm going to slowly bring you through how to write the equations, and obviously enough the question will be to solve for. What do you think I'll ask you to solve? N. Yeah, exactly. So how many equations do you think you need? 3 at least, yeah? So let's take a look at the 3. Now, can you try using Kirchoff's first law, write the equation at this junction for I1, I2, and I3? Simple one, come on. Equation number 1 will be I1, I2, I3. Come on, this is the simplest one. This is the 1 mark you should get out of the 4 marks. Yeah, plus equal, right? Yeah, this is the 1 mark you should get. By the way, the marks distribution usually for this kind of question is 1 mark for each question, 1 mark for each equation, and then probably 1 or 2 marks for the rest of the answers. Now this is where the second law comes in. This is going to be tough. You must follow me closely. I'm going to write the equation for the first loop, and then I would like you to do the equation for the second loop yourself. So let's take clockwise as positive direction. Now how many EMF are there in this first loop over here? 1, right? So therefore sum of EMF equals to sum of PDs. So in this case, the EMF is pointing in the positive direction, so it is 10 volts equals to, it is 6 times I3 plus, this is in the positive direction, this is I2, so it will be 4 times I2. So you must multiply it by the current that flows through the resistor. So in a single equation, you can have different currents coming into play, which you expect it to be because you need 3 equations linking the few variables. Now I want you to do it yourself. I want you to try writing the equation for this loop that goes this way, taking that direction to be positive. There's a reason why I intentionally chose that direction so that you'll get used to negative, because it depends on how I orientate the current and the battery. It can end up with some negative sign, positive and negative in between. So I just wanted you to get used to having the negative sign and following the protocol. Negative because I took the direction, clockwise direction, to be positive. So yeah, if you follow the convention, you will get negatives. But of course, you can simplify the situation by putting everything, the convention as anti-clockwise as positive. Now, are you going to solve this manually, or is there an easier way to solve this? I'm not sure which calculator you're using. If you're using the calculator that Zain is using right now, there's actually a way to solve it. There's actually a matrix function. So what you need to do is, you got 3 equations ready, huh? Now you have to write it this way. I1 plus I2 minus I3 equals to 0. 0 I1 plus 4 I2 plus 6 I3 equals to 10. 2 I1 plus 0 I2 plus 6 I3 equals to 8. Now, if you actually use that calculator, I think it's mode 3, am I right? Or mode 4? Yeah, mode 2. Mode 2, I think. If you use this calculator, it's mode 2. I'm not sure whether the calculator allows it, but yeah. Then you just need to key in the coefficient. This is A1, A2, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3. And then you just press enter, 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 it gives you all your X, Y, Z. Can? Oh. Confirm correct answer one. Also, all you need to worry about is your equations. You don't have to worry about solving the equations. Can?
It's mode 3 too, right?
Mode 3, I think. Mode 3? I think it's mode 2. Mode 3. Then mode 2, yeah, correct. This one, correct. I'm not sure, Joseph, your calculator what mode there is, but yeah. The calculator is mode 3, then 2. The Casio one. Yeah, Shannon, yours is mode 3 too. Then manually solve. It's $25. It's, yeah. 5 over 11 for I1. Yeah. Can you give me in decimals?
0.45.
And I2?
0.723.
And obviously I3 will be 1.18.
Yeah.
Yeah. Good.
It's a bunch of recurring numbers.
Yep. Yep. Now how do you check, how do you confirm stem job that this is the correct answer? There's a third loop. There's a third loop we can use. How do you have a check? Actually, there are 4 loops if you realize. There are 2 smaller loops and a bigger loop. Can you see the bigger loop? So if you take this to be positive, what's the equation going to be? So this is positive 10, this is in the negative 8 direction, this is in the 4i2 plus, this is negative actually, negative 2i1. So if you do this and find that it is 2 volts, then everything is happy. Everyone's happy about it.
So you just ignore the center.
Yep, correct. So you can choose any loop, so long as it is a loop. Yeah, that's the power of this equation. Okay?
What's the fourth?
Sorry?
What's the fourth?
4?
I thought you said there are four.
Oh, there are 3 loops, sorry. There are 3 loops. 1, 2, and 3. 4 equations, but 3 loops. Yeah, 4 equations, 3 loops. Oh, but you have to be very careful. One thing that I need to mention to you is you cannot use 2, 3, and this one. You cannot use these 3 equations to solve, because can you see that these 3 equations actually comes from 2 equations. If you take this and this combine, you can get this. So you will not get 3 unique equations.
You arrive back.
Yes, correct. So you must use the first law and 2 others. Remember this. You have to use first law and 2 others. If you use all 3 from the second law, you'll find that it is undefined. Okay? So because effectively you only have 2 equations. Ready to try one on your own? And I'm going to give you a more difficult one with 3 batteries. So what I want you to do is to find I1, I2, and I3. Give it a try. Try the 3 equations again and solve for it. Okay? 3 batteries. Center one is reversed?
Yeah.
Can still work, then if this equation will become 12, not 24.
But then, like, both ways are going opposite, right? So,
No, but this one will overpower this one. Yeah, kind of overpower. That's a very layman term. Yeah.
so you didn't run for cross, right?
I ran, but I didn't wear the tag.
Oh.
I run for fun. Yeah. My competitive days are over. Now I run because I feel like it. Not because I have to. Just run for fun. Anyway, technically for this kind of distance, it's quite. Even when I'm at my best days, it's not my pet event. Come on, no run is too easy. Even a 100-meter sprint is difficult. Some people train for their whole life for the 100 meters. No distance is too short to be difficult. How do you manage to get the 3 equations? Try not to look up, once you write the 3 equations, then you look up and check. Once you get the 3 equations, use the calculator and find an answer. Okay? Once you get the 3. Now just to show you what I meant just now by that the third equation can be gotten by the 2 equations. Now if you take a look at this minus this, can you see that it becomes 8 equals to 15I2 minus 5I1. Yeah, look at this equation, which is actually the equation for this loop, if you look carefully. 6 volts, 6 volts, yeah. This equation is actually the equation for the third loop.
You just ignore the
So you have to choose either 2 loops and then one Kirchoff's first law. Difficult or not? Not too difficult, huh? Now let me show you how you can use Kirchoff's first law to solve one of the questions that I asked you last week. Still remember this question? No, it is not, unfortunately. This one and this one. Remember the cube one? Every side has a resistance of R. Every side has a resistance of R. Yeah, every line that you see there has a resistance R. How would you find the current? How will you find the effective resistance? Sorry. Yeah. Do you agree that if I were to put in I over here, it will be splitting up into I upon 3, I upon 3, I upon 3? Still we? Now, because of the symmetry. So this one will also come in with I upon 3, I upon 3, I upon 3. This is symmetrical. Yeah? Now, if you go from here to here, it will have to split into 2 paths. So it will be I upon 6, I upon 6. Now then you take any path, from here to here, it will go through 3 segments, any path. 1, 2, 3, 1, 2, 3, either path. And you'll find that if you sum up the PD across here, here, and here, you will find that it will be I upon 3 times R, plus I upon 6 times R, plus I upon 3 times R. Now, do you agree that this sum of PD over here should be equal to the PD across here? That is I times R effective. Right? That means this becomes a black box already. Yes, a R effective. The current over here times the R effective will give me this. Now, boom, 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 boom. R effective will be equals to 5 upon 6R. Yeah. But this is the simplest of the 3 permutation I can give you. The other 2 permutation will be the resistance across here and the resistance across the same side, the diagonal. Those 2 will be much more difficult. This one definitely. The one that I told you, the diagonals and the same side one, is AASB. It's just heavy math, heavy math. The solutions are all over online. You can always search. Classic question, resistors in a cube. Olympiad, physics Olympiad, resistors in a cube. You'll find all the different questions coming up. And the solutions are posted online. You can find out, Ken? Yeah. A higher order version of this question will be this. I got an infinite grid of resistors. It goes infinite in all directions. And then what's the resistance across these 2 dots over here? If each line has a resistance R. You'd be surprised how simple it is. You'd be surprised how simple it is. Okay. Think about this, huh? One of the method requires you to know this method called superposition method. Now, sounds what? Let me show you what superposition method is. This is ASB, ASB, let me yeah, ASB, yes, correct. So don't get stressed out over this. So what is the superposition method? It's actually very simple. Let me show you. Okay. So this one, right? Say, let's give friendly numbers lah. 20 volts 10 volts. This is 5 ohm, 10 ohm, 5 ohm. Okay? So what do you mean by the superposition method? Now let me show you. This is equivalent to this. 5, 10, 5 plus 5, 10, 5. This is 20 volts. This is 10 volts. So what you need to do to find, say for example, I1 is to find IA, IB, and I1 will be equals to IB minus IA. That means you literally superpose the two together.
Does he use this for IT?
No, no.
They not use that.
Yes, because they will not understand what you're doing. To be fair to them, it is not in the syllabus, but it is definitely give you the correct answer. Now, can you see that this is more difficult than the method that you use, Kirchoff's law? You have to find every individual current, so you'll be finding 6 currents. More troublesome. Now, why am I teaching you despite it is more troublesome? Because it's more troublesome for this context. Sometimes it is actually easier for a different context. So I'm teaching you something new so that you can have a wider range of arsenal, to do questions. Sometimes it is easier to use this, and this context is one of them. You'll be surprised how simple this is if you know superposition theory. Okay? But what I mentioned after Kirchoff's law today is ASP. Let me make this very clear. The only IB content is Kirchoff's law. Okay? Cool. Right, and that's the last thing I wanted to go through today. Can you just switch off the Ren? Can you just press the button, please?